Welcome to 1.5, combinations of functions. There are 5 ways that we can combine functions. We can add them together. So this f and g, do not think of those as variables. Those are functions. So this is f plus g of, not times x, but of x. And it looks like we've just distributed the x, and if you want to think about it like that, that's fine, but this just means we're basically combining factories f and g into just one factory called f plus g. Where it used to be 2 factories here, we've just combined it into a single factory that just goes one more step. We make this product, we make a product, they make a product, but then we put the products together. F minus g of x, therefore, kind of stands to reason, would be f of x minus g of x. This is f times g of x, and I far prefer thinking about it, at least in this notation. It's just, think of this as just an abbreviation of those. And f on g of x, that, as far as this section goes, presents maybe the more out there kind of challenges, just because g of x might be a factory that makes zeros, but f on g of x then would have problems when g of x is 0, because of course we can't divide by 0. And you are certainly welcome to look over this and make some sense out of this. I've got a different diagram that I'll set up when we get into f. Some people call this fog, but this is f of g of x, is f of g of x. We put x into g, and whatever comes out of there, we turn around and we put it into the f factory. They do illustrate that, but for my purposes, I believe I've got a better explanation of that. So, short little intro. So we're going to go right on to the first page of examples. And here we have 2 functions given in graphical form, and we're supposed to find f plus g of x. Well, of course, that means f of x plus g of x, which is a great way to say it. But a better way to think of it is the height of f plus the height of g. For instance, at -2, the height of f, so let's see, I'll just put this up here. I'm not going to do this for each of these problems, but at x equals -2, we need f of -2 plus g of -2. The height of f at -2 is 2, plus the height of g is 1. So at -2, we get 3. And I don't think we really need to do that the rest of the way. At -1, we have a height of 0 plus a height of 1. At -1, we have a height of 0 plus a height of 1. So we're at 1. At 0, my heights are -1 and 0. -1 plus 0, -1. At 1, f is at a height of -1. G is up 2. -1 plus 2 is +1. And at 2, our heights are 1 and 2. 1 plus 2, 3. So our graph ends up looking like this. Don't put arrows on the end of it, the graph doesn't continue on. So I think, as you can see, pretty straightforward when we've got these 2 graphs here. So we'll just start from the left. At -3, our heights are -3 and 1, -3 plus 1. So at -3, -3 plus 1 is -2. At -1, our heights are 0 and 2. At -1, 0 plus 2. And then over here at 2, our heights are -1 and 2. -1, so at 2, -1 plus 2 is 1, and we end up with this graph. We're just adding heights together, connecting the dots. Okay, and 14 through 18, I'm going to write small on this because they're asking us to do a few things. I probably should have spaced this out a little bit more, but a couple of them are pretty quick. So in A, we're to find f plus g of x. which I'm going to transpose just into f of x plus g of x, which is just 2x plus 5 plus x squared minus 9, which of course could be simplified into x squared plus 2x, 5, ultimately minus 9, minus 4. And b is the same thing, except we're subtracting those. 2x plus 5, and there's a common mistake made here, the most common algebra mistake, and that would be if I didn't put the parentheses and I just went minus x squared minus 9, I am almost for certain doomed unless I catch that mistake. It's minus all of. So we would end up with a negative x squared. We would end up with just plain old 2x's, but here's the biggie, we'd end up with 5 minus negative 9, 5 plus 9 plus 14. In C, we're supposed to find f times g of x, which is f of x times g of x, which is 2x plus 5 times x squared minus 9. And I'm going to FOIL this and try to do it in one step here. X squared times 2x, x cubed. Then I'm going to see, can I get some x squareds? Yep, only 5x squared. Can I get some x's? Minus 18x. Can I get some constants? Minus 45. And D, f on g of x is f of x divided by g of x, which is 2x plus 5 on x squared minus 9. And that's it. I don't know what we're going to do to simplify. Sure, we could factor the bottom, but the factor of the bottom does not reduce the top. And of course, we can't reduce this x with this x because those are terms. They're part of terms. 2x is a term, 5 is a term, x squared is a term, 9 is a term. You cannot reduce terms. I actually refer to that by saying that every time you cancel terms, a puppy dies, just to try to have some impact on that. It happens at high-level mathematics with very good math students all the time. I get a lot of feedback from our calculus teachers that, hey, let's make certain these kids come in not canceling terms. So the other thing we have to do, notice g of x here is a factory. If I put in 3 and I put in negative 3, it is not a problem whatsoever. I can put anything I want into g. We can square numbers, we can subtract numbers from 9. However, now we can't put 3 and negative 3 in because x squared minus 9 may not be 0 if it's in a denominator. Therefore, x squared may not be 9. And how do we save? Whoops. How do we get rid of a squared? With a plus or minus square root of, and plus or minus square root of 9 is plus or minus 3. Okay, so as we move on, pretty much more of the same. We're going to keep writing small because I really did not give a whole lot of space, but definitely not a challenge getting it all in there. So f plus g of x is just square root of x squared minus 4 plus x squared on x squared plus 1. And here's the good news. I don't think we're going to get anywhere trying to simplify that. B, watch how much harder subtraction is than addition. F of x minus g of x, square root of x squared minus 4 minus x squared on x squared plus 1. C, f of x times g of x is square root of x squared minus 4 times x squared. Well, it's going to end up on x squared plus 1, but that's times x squared. The only thing we might want to do with that is put the x squared out in front. And D, a little bit nastier here, D becomes f of x divided by g of x. And when we divide by a fraction, we can flip and multiply. And we end up with x squared plus 1 times the square root of x squared minus 4, all on x squared. Can we cancel these x squareds? Absolutely not. This x squared is a term of this factor. Now, for domain, there's our domain up here. For our domain, I look at this now, and we've got some issues here. We got some issues because, first off, I notice x may not be 0. That's a problem. However, take a look at this guy. We've got a square root. So x squared minus 4 can't be 0. Well, it can be. That's not true. But I am interested when x squared minus 4 is 0. And therefore, I'm interested when x equals plus or minus 2. And I'm going to use some space up here. I was nervous about running out of space. So 0 is a problem. 2 is okay, but 0 can't be touched. 2 is okay because I can have square root of 0. Negative 2 is okay because I can have square root of 0. Let's test some zones here. If I put in 1, I've got problems. Take a look. 1 gives this problems. I get square root of a negative. So does 0. 0 is doubly bad here. And negative 1 gives me problems. If I put in 3, 3 is okay. 9 minus 4. Negative 3 gives me 9 minus 4. So my domain ends up being, let's do it. So this is bad zone, bad zone. We're just out here, just out there. So our domain is negative infinity to negative 2. And negative 2, watch this, is okay. In union with 2 is okay, gets a bracket to infinity. So I told you we may have some spacing issues here. And number 18, here we go. A, f plus g is f of x plus g of x. And we could get common denominators. We could smash those together. I am completely comfortable for the purposes of this assignment not doing that. Simplified is in the eye of the beholder at times. So b f minus g, x on x plus 1 minus 1 on x cubed. Again, I could multiply this by x cubed on x cubed and this by quantity x plus 1 on quantity x plus 1, smash them together. C, f times g of x is x on x plus 1 times 1 on x cubed. And I think I will write that as just x on, you could distribute, or 1x, excuse me. Or how about this? If I leave this x cubed times x plus 1, can I cancel this x with one of these x's? Yes, I can. So b ends up becoming 1 on x squared times x plus 1. I guess I'll wrap that in there. Oh wait, that was C. Excuse me. That was C. B's right here. That's good. D. F on g is f divided by g, so that's x on x plus 1 times x cubed on 1. And we get x to the 4th on x plus 1. And immediately for domain purposes, I see x cannot equal negative 1. Now, g initially was, g initially, x cubed couldn't be 0. Is that an issue for us? Well, we still have to be able to take this times this. We still have to be able to take this divided by this. So g being 0, that's a discussion that we're going to have as we move on. But can x, equal 0 we got some issues there if x equals 0. It doesn't look like it here, but we're dividing by g, and when x is 0, g is undefined. X may also not equal 0. That will be a discussion that continues on because there's definitely some sneakiness to that. So with that said, I think probably pay number 7, 9, 15, 17 for you might be maybe a 10 to 12 minute affair. So let me know if I can help you, and stay tuned.